welcome to Unit 4 of the Computer-Aided Design and Manufacturing course as CAD/CAM. This Unit 4, we're going to look at programming for CNC milling centers. So by way of introduction, we know that for CNC mill, they are the most common form of computer numerical control machines that you will find. And basically, when you are involved in using the CNC mill in milling a part, it uses commands or GNM codes to program machinery. And these codes are alphanumeric, and each of the code has a designated function to be performed by the machine. So we're going to look at the various codes and what it stands for. We shall look at some videos of these codes and see how they actually command the tool to work on the machine. So in this unit, that's what we're going to do. We're going to study the basic programming commands for CNC mills, and then we'll look at what we call the macro and the subroutine commands, and some advanced features also will be looked at. So for our learning objectives, at the end of this lecture, we should be able to explain the basic CNC milling commands. We should be able to write programs for drilling and milling of simple geometries. We should be able to write subroutine programs into the main programs. So, by way of content, we're going to cover programming commands, codes, and techniques. We're going to have a detailed description of the CNC milling codes, and then we will talk about compensation and offset in milling, and then we'll look at fixed cycle commands. For instance, if you are doing drilling or you're doing any of the fixed cycle commands like boring and all the other drilling operations. That is also categorized in a different way. And then we will look at the miscellaneous commands, which is called the M codes. So we will be covering these by way of content. And then we will finish up with examples using the CNC simulator software that we will install later, called the CATViewer mill. Okay, so if you take a typical 3-axis CNC mill, you have these this is a Haas CNC mill. Haas is a very popular manufacturer of CNC mill, and they are involved in manufacturing all various forms of CNC machines. So these are Haas CNC mill VF4. Now, using this as a demonstration to show the axis of the CNC mill. Generally, if you look at this vertical CNC milling center, the Z-axis is the axis of the spindle, and you notice that from the spindle axis, the spindle axis, you basically have the zero actually starting from here. and that the z-axis going up is positive here and coming down is negative. Now the longest travel on this machine has the x-axis, and then once you travel from this side into the stem of the machine, then you're going in the y-axis. So you'll notice the positive y and the negative y directions, and then a positive x, negative x directions. So you set an absolute zero to actually coincide, to get all these three axes coinciding, depending on the workpiece that you insert in the machine. So if you basically look at this CNC machine, then just as I've explained, you have three directions of travel available on the machine. If you look at it from the number line idea, then you have imaginary lines placed on these axes of travels, and they designate the coordinate positions for x, y, z axis as depicted. Now, if you look at the axis, just as I have explained, you will see that for the spindle axis, the negative travel of the two travel downwards is a negative movement, and then just on the axis you have the zero, so above it is a positive value of the z. Okay, so when you look at the CNC milling center for this typical vertical axis mill, and for most CNC mills, if you take the hard CNC mill as we're looking at, the number line on each center, that is the increments that you can travel, that is if this work table is supposed to move in increments, then the number line on the Harris machine center is equal to 1,000th of an inch. That is every move of the machine is equivalent to 1,000th of an inch. It means it can move in very, very accurate or precise distances. So when you have these lines established, basically it means that every step that you step the machine can be equivalent to 1,000th of an inch. Now, the machine zero position is always set. We say that the z-axis sets the machine zero position in the upward position here, or the two chain position, and it means that it will place all z moves in the negative range of travel. It will place not all of them anyway. So because you will have to effectively move the two up for a two change, all the moves, the z moves here are going to be in the negative direction or range of travel. Now we're going to look at the programming command codes and the techniques for these CNC mill. Now, to maximize the power of modern CNC milling machine, if you are a programmer, you're a typical CNC machines programmer, you have to master the following. You have to master the following 5 categories of programming commands, codes, and technique. Now we will be looking at the first 4, but as a quick let's through the 5. We have basic programming commands. We have compensation offsets. We have fixed cycles, and we have macro and subroutine commands. and advanced programming features, the fifth one, which we will just briefly do an excursion into it. But we are going to cover the first four, with the basic programming commands, compensation offset, fixed cycles, macro and subroutine programs. These are the first four that we're going to cover. Now, if you take the basic programming commands, we're going to look at first, they are just bulleted in this list. We're going to look at motion commands. Motion commands involve these four main motion commands, what we call the G00, G01, G02, and G03. Each of these commands actually commands a tool to perform some sort of motion. That is the tool is used to perform a particular movement. We will come to the detailed explanation of that. Okay. Now these, the next point is we want to look at the plane selection. That is, if you're using the tool in a particular plane, an X, Y plane, an Y, Z plane, or an X, Z plane, there will be a need to select, issue a command which will show the tool to position itself in a particular plane. And so it is either an XY plane or an XZ plane or a YZ plane, and they are designated by these codes G17, G18, and G19 respectively. Now, the next point we will look at is looking at the unit selection. That is, if you are programming, it's either you're programming in you're doing programming in inches or in metric. That is, you are either programming the coordinates using inches or metric. And so it's either you're doing it in inches or you're using metric. And in each case, you either use a G70 or G20 for one set, which is the inches, and then you have the metric with the G71, G21 for the metric. Then we have what we call the work coordinate setting, which we will come to that, is G92. For instance, if you want to move the work coordinate position when we're doing multiple tasks, and then for that task you're doing it not multiple tasks but a repetitive task, then it may be important to shift the work coordinates at any point and then use the same command line to execute the task. That is the work coordinate settings. We will look at reference point return. Sometimes if you want to change the tool may be at the workplace, engaged in the workpiece, cutting the material, and then you want to call the tool to a position where you can change to a new tool. Then there's a need to call the tool to return to the reference position where the tool change will be effected. So you can issue a command to say return to reference position. And once the tool change takes place, then you want to issue a command that will move the tool from the reference position to the position where it was actually working or cutting the material. So we have return to reference and return from reference. Then we have a tool selection or tool change command. That is, if you give a command which is an M command, which is a miscellaneous command, M06, which means you want to make a tool change or you want to select a new tool to work. So if you issue an M06 command, the next command that follows, or what you need to do is to issue It's a two change command, so you have to show the two number. What the two is being changed from T1 to maybe T2 or whatever. So you put the two number that will be needed. Then you have the feed selection, and that feed selection the same way. If you turn the spindle on and it's rotating, and you want to feed the cutter, the cutting tool, that is, if you want to put a feed rate of some number of inches per minute, then you use the F command. Okay. Then we have what we call the spindle speed selection. That is if you want to issue a command to turn the spindle on. And once you issue that command, then you have to show what the speed should be, which you will put S, and then the number that follows will be the speed in RPM. Then we have some miscellaneous functions that we'll look at: M00, M01, M02, M07, M08, and M09. Each of them actually means something different that we will actually be going through it. Okay. So we move on to look at the next other thing that we're going to look at. After the basic programming commands, we look at the compensation and offset. Now, when we talk about compensation and offset, we use them in defining the work coordinate system. Sometimes we can perform what we call a two diameter compensation, and that is accommodating the size of the tool and getting the defined geometry machined. Or we can do accommodation for two length differences when you have a situation where you have to change to a new tool and the length of the tools are different. When that happens, it helps to reduce the programming effort. Then we will look at the main compensation functions, which is the work coordinate compensation, two diameter compensation, and then we have the two length compensation. So afterwards, we look at the fixed cycles. We look at what we call the fixed cycle commands, and that is, we look at the standard phase cycles and some special phase cycles will also be looked at. And then we will look at macro and subroutine programming, where we will find out how we can use the power of the computer programming to define variables and perform some operations and execute the decisions and so on. So that is the macro and subroutine program. And then we will look at some advanced programming features such as scaling, rotation, and mirroring. But we're going to focus mainly in the first four. That is where we are going to focus. So we're going to have a detailed description of the CNC codes very shortly. Now, when we talk about CNC codes, we generally say that G codes are what we call the CNC code, the CNC milling codes or turning codes, called the G codes. Now, they are preparatory functions that involve actual tool moves. That is, they are functions that we're going to study, which you will see that they basically control the machine. So if you give the gene code, the gene command actually controls how the machine moves. Now, these codes involve what we call the rapid moves. The codes involve rapid moves, feed moves, radial feed, dwells, roughing, and profiling cycles. And they are basically codes that command the tool to move in a particular way to perform a particular function. Now, most of these codes described here are model. Now, when we say the codes are model, what it means is that when you issue the code on a line, that code remains active. Throughout until it is cancelled by another G code. So we say that they remain active until cancelled by another G code. So these are the following codes which are going to be described in detail. We have the G00, which is positioning in rapid, which means if you want the tool to move quickly to a new position without cutting any material. We have the G01, which is a linear interpolation, or what we call a linear feed move. And then we have the G02, which is called a circular interpolation, which is a circular feed move. And then we have a G03, which is also a circular interpolation in the counterclockwise direction. We have a G04, which is dual. And then we have G17, G18, and G19 talking about the planes that you will have to work with, that is, whether you're in an XY plane, XZ, or YZ plane. G20 or G70 is for the inch units. G21, metric units, and then automatic return to reference. G29, return from reference point. Then G40, we have kata compensation cancel. 41 talks about compensation to the left. 42 is kata compensation to the right. Then we have the true length compensation, two length compensation plus, and two length compensation minus. Which we are going to describe that very shortly and show some videos of it. Then we have two-length compensation cancel. Then we have work coordinate system, coordinate setting. We have high-speed PEC drilling cycle. We have the cancel cycles. All the drilling cycles are basically called CAN cycles. So when they are issued, then they have to be cancelled after we have completed the command, or the command has finished executing. So before we issue any cycle command which is involving drilling, boring, or whatever, we need to first issue cancel CAN cycles, and then afterwards, then we can also issue another cancel the cycles. And we have G1, which is a drilling cycle, G2 counter boring cycle, G3 depot drilling cycle, G83, sorry. G90 is positioning system. If the coordinate system that you are using is absolute positioning or absolute coordinate system, then you use G90 to initialize the command, so that all the coordinates will be taken from a reference 0 and they become absolute coordinate system. If it's G91, then we are going to have incremental positioning, which means that all your coordinates will depend on the previous coordinate. The first coordinate will depend on the second coordinate will depend on the first one, and then the third one will depend on the second one, and so on and so forth. Now, when you have G92, if you want to reposition the origin point on the workpiece, then you can use the G92 command. If you use G98 command, then you are setting initial plane as a default, and the G99 is return to retract or rapid plane. So these are the basic G codes that we just saw. Now we will then look at the M codes, the mailing codes, which is called miscellaneous codes. They are basically miscellaneous functions, and they are actions necessary for machining, but they don't include actual tool movements. They not involve actual tool movements, and they are basically classified as auxiliary functions, such as you have things like if you want to use the CNC tool, the spindle has to be on and then off. Of course, there will have to be a tool change. There will have to be a need to turn the coolant on and off, and then of course you can have other miscellaneous functions. So these are a quick snapshot of some of the miscellaneous functions. So that's the M codes. Okay, so the CNC milling codes basically miscellaneous functions. The milling codes, that's the M codes that we're talking about here, as M00 program stop, M01 optional program stop, M02 program end, M03 spindle on clockwise, M04 spindle on counterclockwise, M05 spindle stop, M06 tool change, M08 coolant on, and M09 coolant off. You follow through to M10, which is clamps on, M11 clamps off, 30 program end, reset to start, M98 call subroutine, 99 return from subroutine command, and block skip. That is if you want to skip a block. That's if you have some J codes or some command lines that you don't want to the program to execute, then you bring a / to skip it. Now, if you want to put comments in the blocks, you can include brackets. You have an opening and closing brackets, and that means it will see it as a comment. Okay, so let's look at this. That is the first command. So we're now going to take the commands in detail. And the first command is the G00. The G00 is basically a rapid movement of the tool. Now, each of the command lines, if you take a typical CNC program commands, the format is the command line starts with an N and then an integer. Normally, it is in the order of multiples of 5. So if let's say this is my first command line, this could be an N5. Okay, so there will be N5 and then the command will come. And then the next command line could be N10 or N15, N20, N25, and so on. So there's the N in front of the command is showing the command line number. And so the command actually is the G00 and G00XYZ, that is showing the coordinates, X coordinate value, Y coordinate value, and Z coordinate value. So it is actually a rapid tool movement. It's used to use the command to apply by simply moving the tool away from the workpiece without cutting any material. You want to position it. Sometimes you want to issue the tool to move out to, let's say, a home position where you want to do a tool change or do any other thing that does not involve cutting material. So maybe if you have a pattern that you are cutting and you complete one pattern and you want to move away from the other pattern, then you basically want to move the tool away from the workpiece without necessarily cutting a material. So we're going to play the command for you to see that in view. So that will be played very shortly, and that is showing you the Gen00 command. Now it's supposed to position the tool without cutting any material, which will be loading very shortly. Basically, as I explained, you move the tool into position without cutting any material. So for instance, if the tool is, let's say, in a cavity here and you want to move the tool, the ideal scenario is to move the tool vertically up and then away from the cavity. So if you issue a command XYZ, the command will move the tool away. First will execute the Z movement, and then the rest will be the XY movement, and it will not be cutting any material. Okay, so what is important is you have to ensure that when the tool is moved, there will be no obstacle for the tool to run into. So you make sure you give the command in such a way that it is moving rapidly away from any material, or away from any feature that is has the potential of interfering with that tool. Now, if you fail to do that, the result is you could have a situation where the tool will basically damage. For instance, if you move a tool in such a way that you execute a linear motion for first. Normally, if you look at the CNC mill, the mill is having the Z position at the spindle axis of the tool axis. So you have a tool in this position, you want to move it away. So the Z movement will be executed first, clear off the workpiece before an X and Y movement, which is the horizontal plane movement. But if you move the tool, the horizontal first, then you are likely to have a situation like this where you could jam or cause an accident by breaking the tool. So that should be taken note of. So for instance, the Gen00 command, if we want to use it, basically, let's say for example, if you have this as a basic example showing the tool, we're going to have, okay, so we look at the CNC milling codes, that is M codes. We have M00 as program stop, M01 optional program stop, M02 program end, M02 spindle on clockwise, M04 spindle on counterclockwise, M05 is spindle stop, M06 is tool change, M08 is coolant on, and then we have coolant off, which is the M09. Now we have M10, which is clamps on. There are CNC machines that uses automatic clamp, so you can give a command for the clamps to automatically come on, and then you can give a command for the clamps to be off. We have M30, which is program and reset to start. M98 is a call subroutine command. M99 return from subroutine command, and we have the option to skip blocks, which begin with a /. So we have that option to skip blocks is basically if you have a command line and you want to skip executing that line, you just put a / in front of the command line, and when the program gets to that line, it will skip in its execution. We have the comments. The comments, you may include the comments in a block with rounded brackets. That is, if you have and opening and closing brackets. You can type any text in there, and the program will not see it as a syntax, but it will be something that it will accept in the command line. Okay, so we're now going to look at the various commands. That is, we're going to look at the commands starting from the Gene codes to explain the various commands. So the G00 command is a rapid tool move. You just to command the tool to move from its position that is away from the material that is cutting. So you use it to move the tool linearly from position to position without cutting any material. That is very important information, because if you use it to cut a material, it may cause serious damage to the tool, and it could ruin the workpiece as well. It can damage the workpiece. So it is something that you give, and you ensure that the tool will move in a way that will clear off the workpiece without interfering with any feature, and that will ensure that you have the workpiece safe, not damaged, and then also the tool not damaged. So I'm going to play the video to show you what a G00 command actually will imply. Now,
the G00 command is a rapid tool move. A rapid tool move is used when moving the tool at the highest velocity the machine tool is capable of without cutting any material. It's not necessarily a linear motion from position to position. Each axis trajectory may be exhausted before another. This command is not to be used for cutting any material, as to do so would seriously damage the tool and ruin the workpiece.
Okay, so I guess the video explains that. So typically the syntax for a G00 command, we say that the G00 command move should have two distinct movements to ensure that the vertical moves are always separate from the horizontal moves. That's in a typical rapid move towards the parts. Normally you have the two first rapids in the flat, that is a horizontal XY plane movement, then it feeds down the axis. So basically what we're saying is that if you have to move towards the workpiece, then the tool will move in the XY coordinates, that's the horizontal move, towards the part, and then as it approaches the part, then it will feed down along the axis, okay, of the Z. So it means that the XY Z movement will be executed first. So we say that when you are rapiding towards the workpiece, then you execute the XY plane movement first before you feed down to engage the workpiece. And when you are coming out of the part, then the G00 command will always go up in the Z axis first, then it will go the XYZ plane. It will move in the XY, the horizontal plane, next. So as we saw, if you don't follow those basic rules, for instance, if we have this tool here and we are moving it out of the workpiece, we have to ensure that the Z moves out first before the linear moves in a horizontal direction will be executed. If you move it in the horizontal direction first, you will stand a chance of damaging the workpiece. So that is something that we should take note. So for instance, if we take this as a command line, for example, we can say that if this command line is N25 G00 X 2.5 Y 4.75, what you want the tool to do is you want it to move quickly to the position X equals 2.5, Y is equal to 4.75. And the next line, which will be line number 30, this is line number 25. Line number 30 says Z01. Now, when we talk about these commands, we say they are modal